Welcome to part 5 of our live training session here with our Supercharged Honda S2000. In the last tutorial, we looked at the full throttle calibration process on the low cam of operation. This tutorial, we're ready to focus our efforts on the high cam or VTEC operation. We're going to go through how to calibrate both fuel and spark timing, using our knob control to guide us in our spark tuning process. And we're also going to be taking a look at how we can set up and work with our VTEC activation, making sure that it's going to be set at the correct point and that we have the most linear power band possible. We're gonna have a lot to cover. Let's jump in so we can check this out. Welcome back to our live training session here with our Supercharged Honda S2000. In the last video, we calibrated our low cam full throttle area of operation. So for both fuel and spark timing, we got that dialed in. We implemented our knock control. We used that to guide us in making our spark timing changes. We saw that we had a knock event. We backed our spark timing off. So now we've sorted everything out. We've optimized everything. And as a result, we're left with, taking a look at our dyno graph here, about 181 pound-feet of torque and approximately 240 horsepower without VTEC. Now, we're going to be turning on VTEC in this tutorial, learning how to map out our high cam of operation. What we're going to do here is have a separate fuel and spark timing table for high cam operation. This is the exact same process and idea as why Honda implements VTEC on a Honda S2000 engine, for example here. So what we're going to do is take a look at how we can calibrate the high cam fuel and spark timing table. The calibration techniques are exactly what we covered in the last tutorial, but now we're just mixing in the VTEC activation and the specific details here of calibrating on the high cam. Now, a few things with this. Let's start off here in our VTEC fuel page. We can see we're in VTEC fuel. First thing we want to make sure here is that the table 1 and table 2 have the exact same breakpoints in the axes. We're going to find here on our breakpoints for the MGP, these are going to be the same here, or roughly the same. Negative 80, 70, 60, 50, 40, 20, 0. This is negative 180, 70, 60, 55, 50, 40, negative 20, 0. This is actually going to be slightly different on this table. What we're going to do here, let's click on this, let's click on X. We're going to reconfigure this and make sure the breakpoints match what we have here on our fuel table 1. Now, in this case, we don't have negative 80, but we do have negative 70. We have negative 60, negative 50. We don't have negative 55. Let's get rid of that point. We're going to find negative 20, negative 40, negative 20, 0. That's what we find here. Now moving into our load section here, into the boost section here, 5 MGP and higher. This goes from 0 to 20, so let's change that to 5. Then we see this goes to 30, so we're going to change that to 30. Then we can see this goes here to 50, then 60, so we'll go 50, 60. And then we can see it goes here, it goes 80, 90. Let's do that. Let's type in 80 here. And let's type in 90 here. So it goes 50, 60, 80, 90, 100, 120. So we can see they're going to match. We just want them matching just so it's going to be consistent going from both tables. Now, likewise, looking at our RPM, we absolutely want to verify that the last breakpoint in the table here is going to be at least to the RPM or the peak RPM where we're going to be redlining the engine at, and usually a little bit beyond that. So right now it's showing 95. I'm going to go out to 9,500. We're going to 9,000. We're going to 9,500. 9,000 is going to be where we redlined it at. We're not going to go higher than that, but I want to set my highest breakpoint at 95, just in case it goes a little bit past that. It still can generate something for reference for the fuel calculations. Let's click OK. Click yes. So now we can see the table's populated. Now the next thing I want to do is actually just take my table here, and I'm going to simply copy my low cam table into my high cam table. And this should give me a good starting point. So let's just simply copy this. We will find there will be discrepancies. There's going to be differences. We'll have to sort that out when we get to that point, but we want to have a valid starting point. So we're just simply going to copy paste. So we can see it's going to be copy paste between the tables. Now, we have a good starting point to begin with. What I'm going to do, just make sure everything is safe when we get into the high cam. We're going to be moving more airflow. We're going to need more fuel when VTEC activates. What we need to do is raise our table 2 values up here. Let's raise them up about 20%. If it's too rich, we'll take the fuel out. It's better to be rich when VTEC activates than being lean. So I'm going to go here from roughly 9,500. I'm going to go all the way out here, just go back to 0, and we're just going to grab these values. And I'm going to do shift asterisk 1.2. We're just going to add 20%. Now, again, may or may not need that additional amount of airflow estimation to manipulate what the pulse width's going to be, but that's what we're going to start off with here again, just to make sure it's overly rich to get going, and we can always lean out the mixture from that point. Now the next thing we have to consider is going to be our spark timing. If we jump in here to VTEC Spark, We have our table 1, that's low cam. We've tuned that already. We have our table 2. This is high cam. This is VTEC. Again, we want to make sure that the breakpoints match between the table, so 0, 20, 40, 60, 80, 100, 120, 140, 160, 180, and that's going to be the same breakpoints we find here in our load. And we also want to make sure that it's going to go out to 9,000 RPM on our table 2 here. And it does. Everything looks good there. What we're going to do is jump in here and copy the spark timing values from our spark timing table 1 and put them into our table 2. We know we can run at least the ignition timing from low cam on our high cam operation, and in this situation we're definitely going to be able to run more. Whatever the spark timing is, we can definitely run probably at least another 3-4 degrees of timing with VTEC. When VTEC activates, we have a higher lift and duration profile to the camshaft. It has more overlap. As a result, we're going to be bleeding down the cylinder pressure, or the dynamic compression of the engine. The cylinder pressure is going to drop a little bit. We need to make some of that. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.